Hi, this is Alex from devstories.eu. Databricks, episode 15 of 15. Your standard chatbot is polite, informative, and completely passive. It can tell you how to fix a broken pipeline based on a manual, but it cannot actually fix the pipeline for you. Moving from AI that just talks to AI that actively executes tasks requires a fundamental shift in architecture. That shift is the AI Agent Framework. Let us clear up a common confusion immediately. People often mix up simple retrieval augmented generation applications with true agents. A RAG application is essentially a search engine with a language model on top. It retrieves documents and summarizes them. It only reads. A true AI agent has tools. It can write. It can run SQL queries, trigger jobs, and call external APIs. It changes the state of your systems. The Databricks Agent Framework provides the infrastructure to build, evaluate, and deploy these autonomous agents securely within the lakehouse. The core mechanism here is tool calling combined with multi-step reasoning. Instead of just generating an answer in one pass, the language model acts as a reasoning engine. You give it a goal and a set of tools, which are basically functions you have defined. The agent decides which tool to use, waits for the result, and then decides what to do next. Think about an agent designed to monitor data pipelines. When a failure occurs, the agent doesn't just sit there waiting for a user prompt. The framework allows it to trigger a workflow. First, the agent needs context. It uses a custom tool you provided to run a SQL query against your system logs in Databricks. The framework executes this query and feeds the result back to the agent. Here's the key insight. The agent evaluates those logs, identifies the root cause of the failure, and then moves to its next step. It realizes the engineering team needs to know, so it selects another tool, an API integration with your company chat application. It calls that tool to draft and send a message detailing the exact error and the proposed fix. This is multi-step reasoning in action. The agent planned a sequence, executed code, observed the outcome, and communicated the result, all autonomously. Giving a language model the ability to execute queries and trigger APIs is a massive security risk if handled poorly. This is why the Databricks approach tightly couples the agent framework with Unity Catalog. When you deploy an agent using Databricks model serving, you're not giving it blanket access to your infrastructure. You register your tools as specific functions within Unity Catalog. Unity Catalog enforces strict governance over what those functions can do. If you give an agent a tool to query log tables, Unity Catalog ensures it can only read those specific tables. If the language model hallucinates and tries to use the SQL tool to drop a production database, the framework stops it because the underlying function lacks the necessary permissions. The agent is strictly bound by the governance rules of your lakehouse. This capability turns the lakehouse from a passive storage layer into an active automated environment. As we wrap up this series, I encourage you to check out the official documentation and try building a simple tool calling agent yourself. If you want to suggest topics for our next series, drop by devstories.eu. The transition from chatbots to agents is the defining shift in how we build AI applications today. That's all for this one. Thanks for listening and keep building.